So the first thing we would like you to do is start by copying down this chart where we're going to be learning today about exponent laws investigation.
Okay, kids. So, and another reason we're team teaching, please remember, if you're working in math, you can ask any teacher for help on your floor times. But specifically, if you're in Miss David's class, you can ask me for help. If you're in in my class, you can ask Miss David for help. So please remember that all the math teachers in our department know grade 9 math, so they can help you, and try to schedule a period of math a day as much as possible, or a period of math every other day. We're going to concentrate on the hardest rules, and if you've missed anything, it's okay, because I will be posting a copy of the notes. So write as much as you can during the seminar, because note taking is a very important skill. So our whole unit 2 is about powers. It's really important that you understand the components of powers and what they are called. So the bigger number is our base, and that smaller superscript up there is an exponent and a power. Some things we're going to be skipping over that are going to be included in the notes. So when you have 2 to the power of 3, if your unit work is asking you to write it in expanded form, that's the same as 2 times 2 times 2. Now, in grade 9 math, I'm sure Miss David has also mentioned this, we don't like to use the multiplication sign, because that can easily be confused with an X in algebra, and algebra will be our next unit. So when you're expanding and writing out in expanded form, try to use brackets, okay? I'm sure, how many of you have started your unit 2 and have raised your hand if you've done sufficient amount of work? Wonderful. When you are making sure, now we did post some videos about the basic rules of exponent rules, but we are going to go over some of the harder concepts today in our seminar. For example, if you have a fraction and you have a power on top, you are going to apply the power not just to your numerator, but also your denominator. So we have 2 to the power of 3, and that power of 3 has to also hit to the denominator. So the original question is pronounced 2/3 to the power of 3. I should see everyone writing this down, kids. Even if you know it, please include it in your notes. And that power of 3 is going to hit the numerator as well as the denominator. We can write it in expanded form in order to get the final answer. So Miss David and I teach in different subjects. We teach a lot of grade 12 students. Grade 12s learn that every step matters. We're not concerned about whether you can do this in your head. It's really important that you show us your work on paper. Do you want to take the next one, Miss David? I will fast forward a little bit. Not working. I think we'll skip over this time. Okay. And maybe you can explain the chart and the importance of showing expanded form.
All right, so next we're going to talk about product rules. Here, that our first example is our base of 3 to the power of 2. Here we have a dot in the middle, which represents multiplication, followed by another base of 3 to the power of 4. So as you can see, our bases are the same. Both of our bases are 3. However, we have 2 different exponents. Our first exponent is 2. Our second exponent is 4. So because this question is asking us to multiply, what we are going to do is keep the same base, and we are going to add the exponent. This is called product rule. So the expanded form would look like 3 to the power of 2, 3 times 3. Next, we have 3 to the power of 4. That would look like 3 times 3 times 3. Okay? So if we add the exponents, our base will still be 3, and we'll have the exponent of 6. So 3 our base 4 in expanded form, so our base of 4. We do our work for the exponent, so we put the exponent of 3 plus the exponent of 3. So that is how we can also show our work in expanded form.
And it's really important for the test. We do not want just the final answer. You have to show us in expanded form, even with your unit work. You have to show us, are you adding your powers? Are you subtracting your powers? What are you doing with the powers in order to get the final answer?
Perfect. So the expectation is we see 4 to the power of 3 plus 3. We're showing our work that the 2 of the 3's are being added, which gives us 4 to the power of 6. Our next question, we have the same bases in all of them. 2 to the power of 3 times 2 to the power of 4 times 2 to the power of 2. So in expanded form, we write our base, which is 2. For exponents, we show that we're adding all of them together. 3 plus 4 plus 2. So for our single power, we will then have 2 to the power of 9. For our last question, we have separate bases. K to the power of 3 times k to the power of 5. Our base is k. In expanded form, we show our work. We're adding our exponents 3 plus 5. So our single power final answer would be k to the power of 8. So keep in mind, this is called product rule. So we keep the base the same when they're 2 separate bases, and we add the exponents. This is some key information here that we put the rule in a different color because that is important for you to remember.
Can everyone write that down? Product rule, and write that sentence out. That is something that should be in your study notes. I want to remind everyone that we are allowing you to take 1 page of study notes into the test center when you are doing your test. So it would be a really good idea to include that rule on the page that you're allowed to take to the test center. So that is called the product rule. Also, next to product rule, please write 2 separate bases, because when we come to the power of a power rule, students often confuse the power of a power rule with the product rule. So 2 separate bases for the product rule. You have to show that you're adding your exponents. The rule is keep the base the same and add the exponents. Okay, let's move to the next one. So the next rule is the quotient rule. Do you want to go over this, Miss David?
Yeah. So in this rule, as you can see here, we highlighted in green that we are using division this time. So we have 5 to the power of 5 divided by 5 to the power of 3. In expanded form, 5 to the power of 5 looks like 5 times 5 times 5 times 5 times 5. Next, we have division, so we do it as a fraction. On our denominator, we have 5 to the power of 3, so 5 times 5 times 5. What we do this time with our exponents is we subtract them. So we keep our base of 5. We subtract our exponents, 5 minus 3, so we showed us canceling out. And we are left with the exponent of 2. So 5 to the power of 2 will be our final answer. So keep in mind, it is important to show your work. In the next question, we have 7 to the power of 4 divided by 7 to the power of 1. In expanded form, the base is the same, so we wrote the 7. For exponents, we did 4 minus 1. So we showed our work. 4 minus 1 gives us 3. So our final answer, our single power, is 7 to the power of 3. In the next question, we have 10 to the power of 6 divided by 10 to the power of 4. Our base remains 10. We subtract our exponents, 6 minus 4. And our single power gives us 10 to the power of 2. The last example is x to the power of 8 divided by x to the power of 5. Our base remains x. We subtract our exponents, 8 minus 5. And that leaves us with x to the power of 3. So the quotient rule is to keep the base the same, subtract
subtract the exponents. So I would like you to write that down. That is a key rule. I see some of you color code your notes or highlight the important rules. Please try and do that. So if you have a different color pen or a highlighter, make sure you're highlighting the rules. Those are the rules to remember on a test, so that way you don't get confused. And again, if you already have done your unit work, you want to go back and make sure that this step showing that you subtracted your powers or added your powers is there for every question. It was there in the videos that we posted. Something else I want to reinforce, I have seen some students who have shown me seminar notes that only have the rules. You have to have examples for each rule, a rule as well. Don't just watch the video and just write down the rules. Make sure you are writing down every single example, so we know that you've learned something from the videos that we have been posting. Okay, the last one would be the power of a power rule. Now, this is the one that's a little bit tricky because we have one base here, one base and multiple exponents. So the way I would say this is 2 to the power of 2 to the power of 3, 5 to the power of 3 to the power of 4, 10 to the power of 4 to the power of 2. And when we have this rule, again, we don't want to use the multiplication sign because multiplication can be easily confused with the variable x. So we want to write this out as 5 to the power of 3 times 4, 2 to the power, I should write an equal sign here, 2 to the power of 2 times 3, 10 to the power of 4 times 2. So a power of power rule, we keep the base the same and multiply our exponent. That is also related to the 0 exponent rule. And you can see I have this big long number written at the bottom. But anything to the power of 0 is equal to 1. So the 0 exponent rule and the power of a power rule, I think, are one of the final rules that you'll encounter in your unit work. So please, this is an important one. So write these examples down. And now we're going to use all of these rules to tackle some difficult problems.
So please ensure in your notes for power of a power, you're writing down that it has one base, often confused with product rule, which has 2 separate bases. So just make sure you're writing that clearly and making sure that you're writing when there's an exponent of 0, your answer will always be 1.
Okay. So now we're just going to fast forward a little bit. So in the seminar notes that we're going to post, it clearly says with words how we can write out each rule, keeping the base the same, adding the exponents, keeping the base the same, subtracting your exponents. When you come and tell us that you're ready for the test, you really should also come with the set of study notes that you would like to bring in with you for the test. I'm just going to fast forward these a little bit. And we're going to go to the negative exponent rule, if I can get there. There we go. Okay, there we go. I'm just going to put the screen up. So this is the rule that gives students the most problems. And I want you to write this with a big star, star, star next to it, probably the most important rule. So it says any non-zero number raised to a negative exponent is equal to its reciprocal raised to the opposite positive power. That's a lot to take in, so we're going to break that down a little bit further. I've written that word reciprocal in large letters. Reciprocal is in large letters. What does that mean? What did you learn in elementary school about the meaning of the word reciprocal? Reciprocal. Anyone know what the reciprocal means?
May remember it from unit 1 when we talked about dividing fractions.
Okay, so we're going to translate this. So ignore the questions right now. I have a box on the bottom. It says flip the number. Reciprocal means to flip the number of your either whole number or your fraction. So right, step 1, flip the number, which is your base. Step 2, change the power to a positive exponent. And step 3 is going to be to apply the power. Apply the power. Ms. David, maybe you could write that on the board as well, so we can keep that as a record as we go through the questions. So step 1, step 2, and step 3. Wonderful. Flip the base, change the power to a positive exponent, and then apply the power. And I'm going to actually go ahead and erase this. So we're going to start these from scratch. So I have, for my first term, I have an X. What are all whole, can someone tell me what are all whole numbers sitting on top of? All whole numbers, the number 7, the number 9, yes. A 1, very good. So that means the whole number 5, my base of 5, and my whole number X, whole integer X, is sitting on top of an imaginary 1. So can everyone write that? X to the power of -3 has to be sitting on top of an imaginary 1. So I'm going to apply rule number 1 right now. Rule number 1 says I need to flip my base. So instead of X over 1, I'm going to change that to 1 over X. I flipped my base. Can someone tell me what rule number 2 is? Oh, it's not working for me. What is rule number 2? What do I have to do? Yes. Yes. It's really important that that negative power does not mean that my base is negative. It just means I have to apply my negative power rules. So once I flip my base, I can change my power to +3 and now apply that power to both my numerator and denominator. So this becomes 1 to the power of +3 over X to the power of +3, which just simplifies to 1 over X to the power of +3. Okay, so it doesn't have to be complicated. It can be actually quite easy. David, I just erase your back, otherwise it goes crazy. Okay, we're going to tackle the next question. 5 to the power of -2. How can I flip my base? Can someone tell me how I can flip my base? 5 to the power of -2. Any hands? How do I flip that base? Come on, there's a lot of grade 9s. Miko, how do I change 5 to the power of -2? How do I flip my base? 1 over 1/5. Perfect. Thank you. And now remember that negative power does not make my base negative. So I'm going to change that to a power of +2. So that turns into 1 to the power of 2 over 5 to the power of 2, which gives me a final answer. Can someone calculate that for me? What is 1 to the power of 2 over 5 to the power of 2? Jennifer? Close, very close. It's 1/25. Remember, 1 to the power of anything is still 1. So that's a great try. Miss David, do you want to do number 3? And maybe if you stand closer to the laptop, this will switch places, so then it'll pick up your voice.
Okay, so our next question is x to the power of 3 divided by x to the power of 5. So remember from our previous rule that we went over, right now we have our bases are the same. However, our exponents are different. In this case, we have a fraction, so that represents division. Does anyone remember what we do when we have same base with an exponent and we are dividing? What do we do to our exponents? Yes. Perfect. We subtract our exponents. So we're going to keep our base the same, which is x, and do 3 minus 5. So you can see here, I'm showing my work. I have the base of x, and I show for my exponents 3 minus 5. Can anyone tell me what my exponent would then be? Yes. Perfect. So we're then going to have x to the power of -2. Do we stop there? Do we say, okay, now we're done, that's it? No. What do we have to do now? Now we have a negative exponent. So we're going to continue the rules that Miss Albert was going over. So now that we have x to the power of -2, what would be our next step? Yes. Perfect. So what we're going to do is turn it into a fraction. So right now we have 1 over x to the power of 2. Keep in mind the exponent applies to both the numerator and the denominator. So we have 1 to the power of 2 over x to the power of 2. Can anyone tell me what 1 to the power of 2 will give us? Yes. Perfect. So 1 to the power of 2 is 1, and x to the power of 2 will remain x to the power of 2. So our final answer, 1 over x to the power of 2.
So I'm going to give you a second to copy all of those examples down. So this is a clear indication, just because you see that your question starts off as a fraction, when you apply your power rules and subtract your exponents, for a period of time, you no longer have a fraction. So always apply your power rules first before applying the negative power. If your answer, when we got x to the power of -2, if your answer has a negative power, that's when you apply the negative power rule. Okay, so I really want to make sure you're all writing these things down. Don't just listen to us. Write down every question. We're going to get into some more complicated questions now. Let's see. How about we erase some of these? Okay. And we'll start this from scratch. Okay. So do you want to do A and I'll do B?
Sure. Okay, so our next question that we have is x to the power of 5 divided by x to the power of 9. So we know when we see division, what is this rule called? Does anybody remember what we called this rule? Yes. Perfect. Quotient rule. So with that rule, what do we do to our exponents? Yes. Perfect. So we're going to keep our base the same, and we are going to subtract our exponents. So we're going to write x, we're keeping our base the same, to power of 5 minus 9. Can anyone tell me what we will get when we do 5 minus 9? Yes, thank you. Perfect. All right, so we then have x to the power of -4. So please make sure you are showing your work, you're explaining and showing us what you are doing to the exponents. Next, we have a negative fraction, so x to the power of -4. What do we do in this case? We don't like negative exponents. We can't leave it as a negative. We gotta perfect. Do you have any idea what our numbers would be next?
1 over x to the power of
You got it. 1 over x to the power of +4. So our exponent of 4 applies both to the numerator and the denominator. So we have 1 to the power of 4 over x to the power of 4. Can anyone tell me what we would get for our numerator? 1 to the power of 4. 1 times 1 times 1 times 1. Perfect. And x to the power of 4. Does that change at all? Awesome. So it's our final answer will be 1 over x to the power of 4. So in this case, we followed our steps to separate numbers. We kept our base the same. We subtracted exponents. We're left with a negative exponent. We flipped it and did the reciprocal. And we applied our exponents to both the numerator and denominator to get our final answer of 1 over x to the power of 4.
Okay, perfect. Let's increase the difficulty a tiny bit. So I'm going to write the next question larger so that you can see it. So I have 6x to the power of 3 over 3x to the power of 7. So when you tackle questions that have a coefficient, we call the coefficient the number in front of the x. I want to tackle those separately, and I want to tackle my x to the power of 3 and x to the power of 7 separately. Can anyone tell me what I do with 6 over 3? Am I supposed to subtract those numbers? No. What should I do? Someone tell me? Yes. Sorry? Yeah, I could. Well, I need to simplify it a little bit more. Yes? Divide. Very good. So 6 divided by 3, that is going to simplify to 2. 6 divided by 3 is 2. And how do I simplify x to the power of 3 divided by x to the power of 7? What do I do? Subtract. Yes, I'm going to keep the base the same and subtract my exponents. So can someone tell me what happens when I have x to the power of 3 minus 7? What is that going to give me? Yeah, negative. Good. So I have a -4. Now keep in mind my 2 can stay the same. 2 is going to stay the same. It's only my x to the power of -4 that I am going to flip. So that turns into 1 over x to the power of +4, which is the same as 2 times 1 to the power of 4 over x to the power of 4, which is going to give me a final answer of 2 over x to the power of 4, based on what we learned in the first question. So you are going to find that when you're studying for your test, even if you feel very confident with your unit work questions, you want to go and check out the seminar notes that we will be posting to make sure that you understand how to do all of these questions. That will help you give some additional study material for your test. Okay, I think we'll focus on one more hard one, Miss David. I'm gonna zoom in on this question. Yes? Yes, what's your question, Nico? 5/2, and you cannot simplify that. You can leave that question as 5/2. That's a good point. I'll address it one-on-one, okay? Let's see. Or maybe I'll deal with number 8. You want to deal with number 9? Is that cool? It doesn't write on there. Sorry? Oh, do we only have 10 minutes? Okay. What time is it now? 10:30? Okay. Oh, okay. Okay, no problem. Actually, before we go into another question, I just want to quickly show you something, kids. On your TCDSB D2L, first of all, you should be logging into your D2L every day to make sure that Miss David or myself have not updated it with some announcements. So we have our mandatory seminar here. We have our updated floor schedules that you want to make sure that you check. But also, do you see this little ribbon at the very end, the grades icon? You want to go into grades, and I'm not going to scroll into people's grades, but you want to check your grades under the grades icon. If you have a passing mark for unit 1, then you are free to move on to unit 2. But if I'm going to speak specifically to my students, if you don't have a passing mark, I am going to be offering some makeup sessions to help you, where you're not going to write a test, but you're just going to do some activities to bump your test mark to a passing mark. One of those sessions are going to be today. I posted a message today, period 5. Please come to the room across, room 319B, and I will be in there doing some makeup math, okay? So if you don't have a passing mark, you have to either come see me on my floor time or come to one of the makeup sessions. But I really want to see anyone who didn't pass the test today, period 5, in the math area.
The same goes for my class. I've sent TA mail as well as message to on D2L telling you, I believe it's Wednesday, period 1 or 2. In room 303, you're going to meet me there. We're going to do remedial work. So again, we're not going to work on, you're not going to rewrite the test, but we will do other work instead. So if you did have a failing mark, that is the expectation that you show up either during my floor time or the time that I posted on your TA mail. And if you did not write the unit 1 test for both of our classes, it's important for you to come see us to write that test. It is required for you to move on to unit 2.
Okay, so we have a question here which has a number of different variables. Remember, letters are called variables, some different powers as well as constant, well, coefficients, the numbers in front of the variables. So I have 12/4. I want to deal with the 12 divided by 4 separately. I have my k terms, my k variables. So I have k to the power of 2 divided by k to the power of 5. And then finally, I have my m variables. I'm going to do those in red. So m to the power of 8 divided by m to the power of 5. I'm just rewriting and color coding the questions. That's going to help me see how to solve these questions best, how to solve them and tackle them separately. So first of all, my constant numbers or my coefficients, what is 12 divided by 4? So you should see a lot of hands up. What's 12 divided by 4? Yes. 3. Thank you. So that's my answer for that. And now I'm going to switch my color. How would I solve k to the power of 2 divided by k to the power of 5? Yes, so I'm going to keep the base the same and subtract my powers. These are steps that we need to see on your test as well as your unit work. Now, what about my m variables? What am I going to write to help me solve for m? Can someone tell me? What do I have to do? Yes? Good. M to the power of 8 minus 5. So never forget your equal sign at the end. Here I have 3. I know m to the power of 8 minus 5 is going to give me positive 3. But when I subtract my integers, when I use my integer rules for k to the power of 2 minus 5, what is that going to give me? K to the power of 2 minus 5. Jennifer? Very good. K to the power of negative 3. So I'm going to circle that because that negative tells me, negative is like a bad, a negative power is like bad grammar in mathematics. So we need to keep going to make sure that that power is, we get rid of that negative power. So how do I get rid of that negative power? How do I apply those rules on the board? How am I going to flip my base? Someone tell me? How do I flip the base? K over 1 flips to? Thank you. 1 over k to the power of positive 3. And now I'm going to simply write everything else down. Now remember, because these terms are whole numbers, they're going to be on top of a denominator of 1. So I think we've had enough practice to know that 1 to the power of 3 is 1. K to the power of 3 is k. And that has to be multiplied by 3 over 1 and m cubed over 1. So basically, I'm going to keep everything that is originally in my numerator. I'm going to keep that in my numerator. And I'm going to keep everything in the denominator. Oops, I forgot k to the power of 3 right there. So I'm going to write my final answer. 3 and m cubed, those are in my numerator. And all that's left in my denominator is k to the power of positive 3. So when you are stuck on any stage of a question, a long question like this, that's when you're not going to ask your friends. You're going to come to the math area, come to our floor time, and ask your math teacher, how do I do this? We will solve it for you. We will walk you through every step of the problem. But I know that I posted on my announcements, if I see you on my floor time, that means I don't have to call home or contact your parents. But if I never see you asking questions or working in the math area, that's when we have to kind of trigger us that we need to call home, right, Miss David?
Yeah. One thing, a few questions I've been getting about the floor schedule that was posted. You will see 1W on my floor time as well as Miss Albert's and your teachers, but sometimes you might see something like 2D or MCR. That is just their other math courses that they are teaching. So do you want to break that down for them?
Yes, so a 1W is only when I'm available to you as well as my F. That's floor time, right? If you see MCD, remember I teach all of the grade 12s. So that means on a senior block time, if you see any other course code in the yellow and green section, I'm doing seminars for my other students, okay? But there's tons of floor times when we will just see F. And I believe Miss David and I are both in this room together. We teach together on our floor time. So just come to the math area and work and ask questions. Ask as many questions as you possibly can, because otherwise we'll be bored and we'll have nothing to do. So don't get, when you're stuck, don't be afraid to come here and work on math, okay? I do want you to spend the next couple of minutes, if you can book in your agendas, your next math block times. So Miss David and I will be teaching again on day 5, maybe you can write this on the board, Miss David, day 5, period 4, and day 10, period 2.